Suppose we want to use a fraction to describe the shaded part of this circle. One person looking at the situation might say, well, I see that the circle is divided into two regions, and one of the regions is shaded, so I think the fraction is 1/2. Another person might say, no, I see 4 regions in this circle, and 2 of the regions are shaded. So the shaded portion of the circle would be 2/4. And it turns out that both persons would be correct, that 1/2 is equal to 2/4. Now these are equivalent values, these are equivalent fractions, and we need to learn how to change from one form to the other. The 1/2 is a simpler form, somewhat simpler form than 2/4, but sometimes it's important to take a fraction that's in this form and build it up to a fraction in this form. So we want to be able to go both ways with this kind of transition. Let's start with changing 1/2 into 2/4. The way we think about it is like this. 1/2 can be written as 1/2 times 1 because after all, any whole number times 1 is itself. You see, so these certainly are equal to one another. But 1 as a fraction, you see, we can think of 1 as the fraction 2/2. So what we have is 1/2 times 2/2. Now we haven't talked about multiplying fractions, and we'll have a lot to say about multiplication of fractions later. But the way this works is this. I can think of it like this, that this is really just 1 times 2, you see, for the numerator of the product of those two, and then 2 times 2 for the denominator of the product. So 1/2 times 2/2 is 2/4. So 2/4 then is equal to 1/2. And we can build up fractions like that all day long. For example, 2/3 is 2/3 times 1. Well, 1, a form of 1, is 4/4. Another form of 1 would be 5/5. 8/8, 10/10. All of those are forms of 1. And when we multiply by 1, we don't change the value of something, but we certainly might change the form. We are changing the form of 2/3, but not the value of 2/3. And by this multiplication by a form of 1. So 2/3 times 4/4 multiply straight across. 2 times 4, 8. 3 times 4, 12. So 8/12 has the same value as 2/3. Let's do it again. 2/3 again. Now another form of 1 is 10/10. So multiply 2 times 10, 20. 3 times 10, 30. So 20 over 30 has the same value as 2/3. Now, in practical problems, and when we are faced with using this idea, we want to change a fraction to a new one which has a particular denominator a lot of times. For example, here, we might want to change 5/8 into a new fraction which has a denominator of 16. So we have to be very particular about the form of 1 that we use over here in the multiplication process to give us this. And I'm thinking right here because we have 5/8, so many 16ths, I'm going to multiply by the form of 1 right out here. Now, to identify that form of 1 that's to be multiplied, you just ask yourself, what do I multiply 8 times in order to get 16? That is, 8 times what is 16? Well, 8 times 2 is 16. And so if 2 is multiplied in the denominator, you see, to get 16, then 2 has to be in the numerator because we need to be multiplying by a form of 1. So 2 times 5 would be 10. All right, so we're multiplying, notice, by a form of 1 in order to get an equivalent fraction, but in a different form. Now, there's a fast way to do this. The fast track way is to say 8 into 16 goes 2, and then 2 times 5 is 10. Now, when we say 8 into 16 goes 2, all we're doing is identifying the denominator number that's multiplied times 8 to get 16. So 8 into 16 is 2, and we're identifying this. Then we use that same value, 2, and multiply it times 5. And we don't even need to write this, though, if we go through that routine. Now, I'll show another one similar to this in just a minute. But let me show you a kind of a special case of the situation. And it is where we have a whole number, and we want to change it into an improper fraction. And all we do is this. We think of 3 as being 3 over 1. After all now, 3 divided by 1 is 3. So any whole number can be thought of as being over 1. You see, make an improper fraction out of this, and then we can go through the process as we described it up here. Now, just so these fraction bars will be kind of even with one another, I'm going to move this up a little bit. And we probably would not write the over 1 part, except for the first couple of times that we do this. But the reason we do it is so that we can see the number being multiplied times both numerator and denominator. We say 1 into 2 goes 2, and then 2 times 3 is 6. You see, what we're really doing is multiplying this by 2 over 2 in order to get 6 over 2. All right, so 3 has the same value as 6 over 2. And that makes sense, doesn't it? Because after all, 6 divided by 2 is equal to 3. All right, how about 2/3 equals so many 18ths? Now, here's one just like the first one that we had. And again, we are identifying the number to multiply times the 2 just by saying 3 goes into 18 how many times? Well, 3 into 18 goes 6. And then 6 times 2 is 12. Now, all we're really doing is multiplying this fraction by 6 over 6 in order to go from 2/3 to 12/18. Now let's go the other way. That is, let's take a fraction and sort of make it write it in a simpler form. Now that is kind of similar but backwards from what we did just a moment ago. If we have 6/8, then we can think of 6 as 2 times 3. We can think of 8 as 2 times 4. And the two factors here can be kind of separated from these two factors. You see, the two 2's can be thought of as 2 over 2 times 3/4. But 2 over 2 is nothing but 1, and 1 times 3/4 is 3/4. Now, we don't go through all of this when we reduce fractions, and that's what we call this, is reducing the fraction. We'll end up thinking about the 2's as canceling like this, and when they cancel because they become 1. So we can just cancel them like this and write the fraction 3/4. Now, an even faster way to do it would be to say that 2 goes into both the numerator and the denominator. You see, and by dividing 2 into both of them, once again, we're just kind of taking out that 1, you see, that we see within those factors. So we could say 2 into 6 goes 3, 2 into 8 goes 4, and very quickly reduce the fraction. But this is the basis of the reduction idea. Let's go through it again. Now, I want to make sure we understand that all we are doing is eliminating like factors in numerator and denominator by reducing in this way. And I'm going to take the long road here one more time. 30 can be written as 2 times 3 times 5. You know, it's 6 times 5, and 6 is 2 times 3. Okay. And 12 is 2 times 2 times 3. So these are like prime factorizations for the two numbers. And what we see when we stretch out the factors is we see the two 2's and we see the two 3's, and then we have the 5 over 2 remaining. And this is nothing but 1, and that's 1, and this is 5 over 2, so we have 5 over 2. It's an improper fraction here which can be changed into 2.5. But, oh, and by the way, this is improper. You might have thought, well, gee, it's an improper fraction. Why don't we change it to a mixed number early in the problem? And you could do that. That's just another way to get to the same result. But this business of reducing, of eliminating the two factors in numerator and denominator and the three factors in both numerator and denominator, we can do in a much more speedy fashion. We could, if we go to this form, we could say the 2's go out, the 3's go out, and we have 5 halves left. That would be fine. Another way to do it is to just take 30 over 12 and to begin to cancel like this. Now, I'm going to show it over here. And I want you to know that there are a lot of right ways to deal with this. One person might say, well, now all I'm doing is eliminating like factors in both numerator and denominator, and the process is called canceling. All right, one person might say, well, I see that since the two numbers are even, that 2 will go into both numerator and denominator. So I might think of this as 2 times 15, and think of this as 2 times 6. And now the 2's go out, and I have 15 over 6. And then someone might say, oh, well, wait a second, I got 3's that go into both numerator and denominator here. Or you might say that I can factor both numerator and denominator by yanking out a factor of 3, or rewrite it in terms of a 3 factor, using a 3 factor. So the numerator is 3 times 5, the denominator is 3 times 2, the 3's go out, and I have 5 over 2. Somebody else might say, well, wait a second, I can see that in 30 over 12 that 6 is a number that goes into both the numerator and denominator. I could write this as 6 times 5 and this as 6 times 2. And I can eliminate those 6's and get 5 halves a little quicker. And somebody else will say, well, gee, why do we even have to write that step? Why don't we just take 30 over 12 like this and say something like 6 goes into 30 5 times and 6 into 12 goes 2, and we have 5 over 2 real quick. You see, and all of this is correct. All of these are right ways to deal with the situation. Let's practice on a few problems. We have 8 over 60. I think a good way to approach the problems like this, fractions that have where the numbers in the numerator and denominators are fairly large, is to chip away at it. You don't have to find the largest factor that's common to both the numerator and denominator. That's really nice if you can do that. But it takes some time and mental energy to do that. And there's no sense in wasting that time, because if you can just identify a single factor, a small factor that is common to both the numerator and denominator, then eliminate that factor and you have made the problem much simpler. Here's what I mean. If we have 8 over 60, then we see that they're both even numbers. So we can write this as, well, let's see. Now, the first few times you do this, you're going to want to write the factors like this. You see, 8 is 2 times 4. If I notice that they're both even, then I know that 2 goes into both of them, and I can write 8 as 2 times 4. I know that 2 goes into 60 30 times, so I can write 60 as 2 times 30. And the 2's go out, and I have 4 over 30. You see, that is a way to deal with it. And then when I have 4 over 30, I notice, oh, gee, even numbers again. And therefore, I can again rewrite in terms of 2 times some other factor and eliminate those 2's. The faster way to do it from here is to say 2 into 4 goes 2, 2 into 30 goes 15. So the fraction here now, when the smoke clears on this, is 2 over 15. So once again, a lot of ways to do it. Now, the problem can become rather convoluted or messy if you use this method of cancellation like this, and if you haven't left enough room. Now notice I don't really have enough room here to write the 2 anywhere upstairs or the 15 down here in the denominator. And if you're going to use this method, then it's wise to leave yourself an awful lot of room. If we had begun to do that, let's do that on this problem. Let me show you what I'm talking about. I have plenty of room to start with here, and I don't want to paint myself in a corner. So what I would do is I would think, well, let's see. I know that 2 goes into both 24 and 18, and rather than rewrite as 2 times something and 2 times something and eliminate the 2's, I can do it right quick like this. 2 into 24 goes 12. 2 into 18, 9. You see, now I have 12 ninths. So 24 over 18 reduces to 12 ninths, I know that. But I see another factor that's common to both the 12 and the 9. I see a 3. 3 into 12 goes 4. 3 into 9 goes 3. So now I have reduced to 4 thirds. So 24 eighteenths becomes 4 thirds. Another way to deal with it. 44, oh, and by the way, if your instructions may be to just reduce and not worry about improper fractions. If we're concerned about improper fractions and we need to write them all as mixed numbers, which may be the case in our directions, then we would have to change this to, well, let's see, 3 into 4 goes 1 with 1 left over. So this is 1 and 1/3 as a mixed number. Here's 44 over 60. And if I'm going to reduce this, I kind of favor methods where we can see everything that we have done. Once we're finished, we can see everything that we've done. And the reason I favor that is because if you ever have occasion to go back and check to see if it's right, or if you make a mistake and you want to find out where you made the mistake, then it's important to have everything illustrated so that you can find it. And one way to do that is like this, is to go through the notion of, okay, I see even numbers. Rather than strike out here, I'm going to write this as 2 times 22. You see, and I'm going to write this as 2 times, it would be 30. And the 2's go out. And now I see 22 and 30 are both even, so gee, they're divisible by 2, or they can be written with a 2 factor. So 22 is 2 times 11, and 30 is 2 times 15, and the 2's go out, and so this becomes 11/15. So I kind of like that way of doing things, because if we ever had to look at it again, we can see that we broke 44 down into 2 times 22. We broke 60 down into 2 times 30. You see, we can see all of that by using a method like this. All right, for 33 over 110, wow, well that's interesting. I wonder if we can even reduce this one. Well, to investigate the possibility, we just need to realize that we're trying to find a factor that's the same in both numerator and denominator. Now, 33 is a number that doesn't have very many factors. I mean, 1 in itself, of course, but there is another way to break down 33, and it is with 3 times 11. So we might want to write it as 3 times 11, and then, because 3 and 11 are the only factors in the numerator, we would be on the lookout for 3 and 11 to be factors of the denominator. Now we might think, well, does 3 divide this denominator? Well, let's use our divisibility test for 3. The divisibility test says to add the digits, and if 3 divides the digit sum, then 3 divides the number. But the digit sum is 1 plus 1, 2. 3 doesn't divide 2, so 3 doesn't divide 110. What about for 11? Does 11 divide this number? Well, yes, it does. We can see it by long division here if we want to write it all out. 11 goes into the 11 one time. 1 times 11, 11. Bring down the next digit. Oh, we need a placeholder up here. 0 times 11 is 0. So it goes 10 times. So we can write this denominator, 110, as 11 times 10. And now the 11s can cancel, and we find that the fraction reduces to 3/10.